So solutions for quadratic functions. And we're just going to talk in general at first. Doesn't matter what form it is in. There are three solutions, or not three solutions. There are three solution types. So types of solutions is what we're going to start with. And there's three of these. And you should be writing all this down. Okay, so first type, we're going to do 3 columns. Oh no, my blue marker is, wow. Oh, wrong blue marker. That's why. So the first one solution. The solutions are where the roots are, which is what we talked about last unit. It's like the last thing that we did. The roots are where the graph crosses the x-axis. So if there's one solution, then it just crosses at the vertex. So for all of these, it's going to be some coordinate point with a number, comma, 0. So there's one solution. This would look like this would look like x minus, so y equals x minus 3 squared. All right, we moved it 3 to the right, but it didn't move up. So the vertex is the solution. So for this, the solution is 3, comma 0. We'll talk more about how to do these in a bit, how to solve them. But for now, we're just saying, okay, it's possible that there's only one solution. It only crosses at one point. That marker doesn't work. This one does, though. Okay, then the other possible solution type is that there are two solutions. Two solutions. So this would look like, oh yeah, whoops. This would look like we have our coordinate plane and the graph crosses twice. So we have two sets of x comma zeros. This would look like, what's something with the solution? So they could be in any form. So we can just do this in root form, where x is x plus 2 and x plus 4. And so the solutions are negative 2 comma 0 and negative 4 comma 0. So we have two solutions. Both of those we have thought about before, or we have looked at before. There's another one that we're not really going to focus on yet, because we're not going to do imaginary numbers till next week, but where there are no real solutions. If we're thinking about the different possible positions for our parabola, right? We could have the curve just touch the x-axis at one point where the vertex is. We could move it down and now the curve is touching at 2 points, this x-axis. Or what if it doesn't touch the x-axis at any point? What if it's up here? What if it's up there? And so this would have no real solutions. So an example of a function that looks like that is, I'm going to put this in vertex form because it's easiest for me to think of one on the spot. But this would be like x minus 4 squared plus, I don't know, 2. And so there's not a real number that we can put in for x for y to be 0. Mostly because of this plus 2 and the way that the square works. We can't get, real numbers don't give negatives out of the square. So we will eventually talk about imaginary numbers where that is possible, but for now, it says no real solutions. It's going to have solutions, they're just not real, which is confusing, I know. Here, let me actually do this. You can see all. So basically, we're looking at the position of the graph. We don't need to graph it to think about these because we're going to solve them algebraically. But we're looking at the position of the graph. Touches at 1 point, touches at 2 points, and it touches the x-axis at 0 points. Types of solutions. These will also be on YouTube later. Yeah. So this is solution types for quadratics. Next chapter, we're going to look at polynomials, and we're going to have more solutions, right? There are functions that have 5 solutions and 3 solutions and more solutions because it crosses the x-axis a bunch of times. But for now, we're just looking at squares, right? Quadratics. So it's going to either have 1, 2, or no real. No real being imaginary. And we'll talk more about how imaginary is a really bad name for what it is, but it's fine. It is what it is. Okay? So we want to talk about how to solve. How do we find the solutions? Well, the solutions are just where the roots are. And we call this solving a quadratic, which just means find the solutions. Find the, well, whatever. That says the roots. I just made it one word because spaces are hard, apparently. Find the roots or solutions. Because the roots are the solutions. So algebraically, find these things. We have a couple methods. We like methods. And I'm going to list them first. And then we'll do some examples. So methods. Now there's a bunch. We're not going to do all of them. I'm not going to list all of them either, but I'm going to list the ones we're going to do. So the first one is square root. And we'll talk about which one to pick and why, but you pick this one if there's no b value for standard form. There's no b, or in vertex form. So that's when we would use this method. We're going to take the square root if it's in standard form and there's no b value, or if it's already in vertex form. We'll do examples for both of those. Okay, the second method is to factor and find the zeros. You would do this when it's factorable. Sometimes it's not factorable. there's not, do I know how to know if it's factorable or not? No, I don't. There might be a way to know, I just forgotten it. Third step, third method is the quadratic formula, and we're saving this for last. So we're not going to do this yet. When would you do the quadratic formula? Anytime. If it's in standard form. It's not really super useful if it's in root form. So this would be when factorable / factored form already. Okay. And basically what we're trying to do is find the coordinate points where y is 0. So each of these strategies is going to do that. We set y equal to 0 and then solve the function. Solve by a number of methods, but basically get x by itself. And the first one is not the easiest. I think the quadratic formula is the easiest, but the first one is the simplest. Because quadratic formula is actually kind of complicated. You got to find all the numbers and plug them all in and then simplify. By just taking a square root, we're doing the inverse of the square. Okay, and I'm actually going to do this on another piece of paper. I know I have like a little room, but I don't think that is enough room to do what we need to do. Okay. Do we need more time writing? I know it's a lot of words, which takes us longer to write, I think, than the math. We've already been going for 20 minutes. Goodness, we're going to run out of time. Okay. So method 1, example 1. Solve y equals x squared minus 8. We'll do some easy numbers first, because we haven't talked about square roots yet, but we will next week. So x squared minus 9, we want to solve this, which means what value of x makes y equals 0? So here's what we do first. This does not have a b value. This is in standard form, right? A is 1, b is 0. I need to change colors. I'm going to write that out. A is 1, right? It's in standard form. It just doesn't look like it because b equals 0 and c equals negative 9. You could factor this. We're not going to because there's an easier way. So you can factor this. You can be like, oh, right, I'm going to factor that into x plus 3 and x minus 3. And use the x, and you could use the box, and you could do all those things, and you could factor it. Or you could say, all right, our first step is 0 equals x squared minus 9. We want to figure out what x is when y is 0. So we just make y 0. And then we're going to do inverse operations to solve. So make y 0. And then inverse operations to solve. And it has been a long time since you have done this specific inverse operation. Not the first one. The first one's easy. The first one is get x by itself. We add 9 to both sides. And then it's 9 equals x squared. How do we get rid of the square root? What's the inverse? How do we get rid of x squared? What's the inverse of the square? Well, the inverse is the square root. So we just take the square root of both sides. Square root of 9. Yeah, Lily. Square root of 9 equals the square root of x squared. And we need to remember something that I'm going to write over here. This first. Okay, two things. One, the square root of x squared is just x. This is important information that you should not forget. Now I say x, but like anything could be in that x, so it can be parentheses, which we'll do in just a second. So that means that this, I don't want to use purple again, I want to use a different color. This right here, square root of x squared just becomes an x. The other thing that we need to remember is that when we take the square root of something, there are two things that multiply to make it. Because 3 squared equals 9, and negative 3 squared equals 9. There is a faster way to write this. How can we write both positive 3, right, because 3 times 3 is 9, and negative 3 at the same time? Yeah, Lily, perfect. So you're going to write plus or minus. This is called the plus or minus symbol. So plus or minus 3. And this is going to come up in the quadratic formula, but it's going to come up a lot of places where we're saying, okay, the possible solutions for x are positive 3 and negative 3, right? X equals 3 and x equals negative 3. So you can write it both of these ways. You can say plus or minus 3 equals x, and I don't know the shortcut to type that, so if you have to type it, I don't know. But you can say x plus x equals 3 and x equals negative 3. There probably is a way to type this, but off the top of my head, I don't know it, and we would have to Google it to find it. Okay? So then we're done. We found the values of x that make y equals 0. So we can write it that way, or we could write it as coordinate points. Any of these three answers are all the same. We have said the same thing many different ways. So you don't need to write them all. You just pick one. I like this first one because it's a lot less writing, right? You just say plus or minus 3. Now for now, we're going to do, well, I hope I don't remember what the quiz is like, or this practice thing that we're going to do. For now, we're just going to say, all right, we're going to have easy square roots, and we're not going to have to find all the factors, and we're not going to do like the square root of 27. But we will do that eventually. Okay, so if you see an x squared, and it's by itself, or basically there's not an x in this variable, in the equation, right? It's x squared, b is 0, and it's minus 9. We don't have like x squared plus 3x. We can't take the square root of that because we have an x by itself. So that's our first example for that. Let's do another one. So this is the same method. Y equals, oh, I want the numbers to be easy. Shoot. What do they need to be? 8, I think? No. Yeah, 8. And minus 8. And then this can be anything here. Plus 2, sure. Okay, so this is in vertex form, and we're going to solve quadratic. Now, normally a problem wouldn't be written like this. It'd be written the other way, like solve this quadratic, and here's the equation. Now, you could multiply this all out, right? Do x plus 2 times x plus 2, multiply all that by 2, subtract 8, and then you could factor it. It's factorable. Or plug it into the quadratic formula. So you could put this in standard form and then solve it, but let's not do that. Let's do what we did before and just say, okay, to find the solution, y equals 0, and then we go from there. So now we're going to do our inverse operations using Pemdas or gems to solve. So first step is make y 0. And then we use Pemdas or gems. So the first thing we do, since we're doing inverses, we're going up. We do the opposite of addition or subtraction. So there's a minus 8, so we do plus 8 to both sides. And so we get 8 equals 2 times x plus 2 squared. And then we do the inverse, the next inverse. So we are at multiplication. What's the inverse of multiplication? Division, right? This is all times 2. We could distribute, we could multiply the binomial and distribute, but it's easier to just divide by 2 on both sides. And so we get 4 equals x plus 2 squared. And now we have an exponent, right? We have this 2. So we need to do the inverse of the exponent, which means we're going to take the square root of both sides. So the square root of 4 equals the square root of x plus 2 squared. So here we did sum, we did multiplication, we're doing our exponent, and our grouping symbols. So this becomes plus or minus 2, right? Square root of 4 could be negative 2 times negative 2 or positive 2 times positive 2. And so this equals x plus 2. Now we have a problem. Gems over here. We undid the grouping symbols. Now we have a problem because we're going to subtract 2 on both sides. And so we get negative 2 plus or minus 2 equals x. Well, that plus or minus 2 means that we have 2 solutions, and one of them means we add 2, and one of them means we subtract 2. So really, this is 2 problems. Negative 2 plus 2 equals x, and negative 2 minus 2 equals x. So we're taking this plus or minus, and we're turning it into addition and subtraction. So we're getting 2 answers. This just turns into 0. And this turns into negative 4. So our solutions are not plus or minus 2. It's 0 and 4 because we started at negative 2 here. Or we started at plus or minus 2. So x would be 2 and negative 2. And then we have to do this minus 2 on it. I think I just made no sense with what I said, but hopefully we get the idea. The plus or minus means that there's 2 solutions, and we need to account for both the positive 2 and the negative 2 by adding and subtracting. And so that gives us 2 different values. You can think of it like the axis of symmetry is at -2, and we go 2 to the right and 2 to the left. And so this is where our roots are. And our axis of symmetry is in between those. It's the -2. When we do the quadratic formula, hopefully that negative b over 2a formula we used becomes a lot more clear as to why that works, because that's where the axis of symmetry is. And then we add a bit on one side and subtract a bit on the other side, and that tells us where the roots are. So that's getting a bit ahead, but basically for this, you do inverse operations, and then you solve for the couple values of x. I am not going to do another example like that right now. If we need it, maybe later. But all of this inverse operation stuff is stuff that we have done before. The newish thing, the new thing, is doing the inverse of the square. And it's square root. The inverse of a square is to take the square root, just like the inverse of a cube is to take the cube root. And we will talk about that more later, like the cube roots and all that stuff. But for now, just inverse of the square is the square root, which you've seen before. So hopefully we can do that. Okay. So that's method one, taking square roots. We're undoing the square to find the possible values of x, and there's usually going to be two. Sometimes there's just going to be one. Sometimes. But usually there's going to be two. Maybe we should do one where it's one. I mean, where there's only one solution. Nah, it's fine. Okay. Method two. All that factoring stuff we've been doing. Solve y equals, and I'm going to steal an example that we have already done. This is an example from the homework. 6x squared plus 7x minus 49. So on Friday, we did this factoring. You already have this factoring in your notes. I'm going to do it again. Right, so we list out A, B, and C. 6, 7, negative 49. We do the x. We got negative 294 and 7. Right, so this is AC, this is B. And then we used a calculator to figure out the numbers that multiply to make 294 and add to make 7. Or we use Google, really. And so we said those numbers, which are hard to find. I don't expect you to just know them on the top of off the top of your head. What we did was we guessed and checked. So like, does 10 work? No. Does 11 work? No. Does 12 work? Yes. Oh, no, it doesn't. It was 14. So 12 didn't work, 13 didn't work. It was 14 and 21. And I did not do that by hand or in my head. I had the calculator. I had a calculator to figure that out. So when we add these two, we get 7. When we multiply them, we get 294. And so then we filled out our box. And so we said 6x squared because the inside of the box needs to add to these pieces. So 6x squared minus 49, and then this one's negative 14x, 21x. Oh, my camera's covering stuff up. So here. So the inside of the box adds to make our original function. And then we just factor out the pieces that are in common. So we have negative 7 here. These have a negative 7 in common. This has a 2x. This has a 3x. And this is 7. So here we're saying, okay, what do these have in common? They both have an x in common. And then we have 6 and 14, so there's a 2. I can divide both those by 2. If I divide both those by 2, that means this has to be negative 7, this has to be 3, which leaves this being 7 because 7 times 3 gives us 21. So y equals 3x minus 7 times 2x plus 7. The reason I'm doing this example is because our solutions are going to be fractions, and I want you to see that and get used to it, because what we're going to say is, all right, our first step is just turn y into 0. And then last chapter we said when we're finding the roots, we just need each parenthesis to be 0. Right? Because if I have a value of x that turns this whole thing into 0, when I multiply this by 0, it will all just turn into 0. So this is going to make one equation, and this is going to make my other equation. So 0 equals 3x minus 7, and 0 equals 2x plus 7. And my face is in the way again. But we just take each piece and make it equal to 0, because if this parenthesis equals 0, then when we multiply, the whole thing equals 0. We did this last chapter when we were finding roots. The problems were simpler than this, right? We didn't really do fractions, but you need to be able to do the fractions. So now we just solve for x, and we're going to get fractions. The reason I know we're going to get fractions is because the number here in front of x is not 1. So we add 7 to both sides. We get 7 equals 3x, which means divide by 3, and so x equals 7/3. And that's it. You just leave it like that. You just leave it like that. Over here we would subtract 7. So we get negative 7 equals 2x, divide by 2. And so x equals negative 7 halves. And those are our two solutions. I did that a little quickly. Those are our two solutions. Those values, those fractional values, or decimals, you could convert them to decimals, but don't. Just leave them. Those values are the values of x that turn the function into 0. Now, there are easier ones. They're not all going to be this complicated because they're not all going to have fractions, right? If we were to do, we're not going to have time to do the thing I wanted to do. It's fine. This, it's already factored for us. And so we just say, okay, 0 equals x minus 3, x plus 4, which means x minus 3 equals 0. X plus 4 equals 0, which means x equals 3, x equals negative 4. So they don't need to be this complicated. And I'm doing these really quickly. But they don't need to have fractions like this. It's just there will be fractions if the numbers in front of the x here after we've done our factoring is not 1. If it's 1 right here, well, we're not going to divide by anything. We're just going to add and subtract. And so we're left with these. Okay? Let me look at the thing that we were going to do and decide if we have time. Regardless, I want us to try. Okay, so here's what we're going to do. I'm going to upload PDF. I want you to open the PDF. It's all multiple choice. I went through those notes so quickly. It says Mrs. Lynch on it, but that's fine. This is just practice for the quiz that's going to be not today. Do I want this to be homework? Maybe. That's a lot of homework this week, though. Well, regardless, we have 20 minutes left right now. I want you to get as much done as you can on that PDF. So you're just solving. And if you get stuck, you should ask for help, okay? Because what we're going to do is I want you to put your answers here. So this is just multiple choice, so it's only asking for multiple choice answers, right? But work the problem out, and if we get stuck, I will totally help you. You're like, I don't know how to do, what do I do for number 1? Well, that would be like the first example we did. Okay, so we got 20 minutes. So do as many problems as you can, put them into the form. I want to know how we're doing. The quiz is going to be Thursday. We've technically talked about everything on the quiz, but I do want to make sure that if we need to on Thursday, instead of just talking about imaginary numbers and doing square root practice, we may go over some problems if we need to, depending on our results in the form. Okay, so get started, and if you have a question, you can be like, I need help with number 2. Type it in a chat or send me a message, and we can work on it.